Okay, this video covers 2.3 and it's part 3, using a formula to solve a real-world application. Number 3, it takes Andrew 30 minutes to drive to work in the morning. He drives home using the same route, but it takes 10 minutes longer. He averages 10 miles per hour less than in the morning. How far does Andrew drive to work? So we know his rate is slower, so it's going to take him longer. So first of all, there's a little typo here on the second to last sentence. So it should say in the morning, not just in the morning. So if we have our formula is distance equals rate times time, you can write it as capitals or smalls. It's fine. Just kind of be consistent within a problem. So the time to work, so I'm going to call that, that's the time, is 30 minutes. So T equals half hour is 30 minutes, since our other information is given in miles per hour. So we'll just write that right out the bat. And then the rate for to work. So this is to work info. So the rate is just R. We don't know it, so I'm just going to leave it as R. And then to home, that info, I'm going to put over here off to the right. The time is 10 minutes longer, so that's going to be 40 minutes. And then let's convert that to a fraction also, to be an hour, 2/3 of an hour. The rate, again, we don't know, but we know it takes him 10 miles per hour, like less is his average speed. So we're going to go R minus 10. Okay, and we don't know that. We're going to have to figure that out. So then I have distance to work, D sub W equals D sub H for home, because I know, it's the same place. He didn't vary how he went. Now, just like the phone plan problem, where we wanted to see when they have the same value, overall cost, we set them equal to each other, the equation. So we're going to do that here. So distance to work would be the rate, which is R, times time. So we're going to write that as half R instead of R times a half. It just looks better like that. And then 2/3, we're going to set that equal to 2/3 times R minus 10 for the rate home. Now all I need to do is solve that. Yes, there's some fractions involved, but we've been dealing with those, so shouldn't be too bad. So I'm going to have you stop the video there, and you can go ahead and distribute, see how you do with those fractions on your own, and I will write out the steps as well. But once we figure out the rate, we're not quite done. We have to also then go back and plug that in to distance equals rate times time, using one of these, either the distance to work or distance home, to find out the distance. So here I've arranged my equation. So I had my given information. I had my equation half R equals 2/3 times quantity R minus 10. I distributed, I get half R equals 2/3 R minus 20/3. And then I just wrote out how I did my math for the fractions. I would have a half R becomes 3/6 R. And then I am subtracting the 2/3 R from both sides, but getting an equivalent fraction with a common denominator. So I have 3/6 R minus 4/6 R equals negative 20/3. Then I simplify each side, multiply by the reciprocal, and I get R equals 40 miles per hour. But the question asks, how far does Andrew drive to work? So we need to convert that over to distance. And we have two formulas here for distance. We have the distance to work is half r. We have distance home is 2/3 times quantity r minus 10. Well, the easier one to work with is the distance to work, and they are the same. So I can just go ahead and plug it in as a half of 40. So distance to work actually is the same as, overall distance is a half times 40, which would give me 20. And the half is in hours, the 40 is in miles per hours. The hours actually cancel out. So then we would have 20 miles. And then it takes, or he drives, we could say he drives 20 miles to work. It's just asking for that one way, not both ways. So that's the importance of interpreting your answer to and kind of going back. Did you answer the question? That kind of thing. The number 4, the next one, is a perimeter problem. I feel like these you've probably had a lot of, and probably the area problem as well. So I'm going to read it and have you try it, and then I'm going to work through it kind of quickly. I'll write it out and then go through it with you. It says, number 4, the perimeter of a rectangular outdoor patio is 54 feet. The length is 3 feet greater than the width. What are the dimensions of the patio? So you might want to just start by drawing a little figure of a rectangle. We usually call the length the horizontal line across, and the width is the up and down vertical, but it doesn't really matter. So go ahead and see if you can piece that together using that perimeter formula we talked about earlier. Okay, so working through this problem, we have length equals w plus 3, and the width I'm just going to call w. The formula is p equals 2l plus 2w, and I'm just going to fill in everything I have. So I have perimeter was given as 54 feet, and then the w plus 3 for length just get substituted in there. So I have 2 times quantity, w plus 3, plus 2w, and then just solving that down as an equation, I end up with 54 equals 4w plus 6, and then 48 equals 4w, w equals 12. So once I get that 12, that's just the one side, the width. Now I have to put it, kind of back sub that back in for the w plus 3. So length is w plus 3, so that would be 12 plus 3 equals 15. And now the question asks for dimensions, so you want both of those, and make sure you include your units and just say the dimensions are 12 feet by 15 feet. And that would be it. The next problem, number 5, that one is an area problem. So we have the perimeter of a tablet of graph paper is 48 inches squared. The length is 6 inches more than the width. Find the area of the graph paper. So again, we have to put the width in terms of the length, or vice versa, however it works out. Usually just whatever one you know least about is the one that you call X, or in this case we can just call it W. So I'm going to let W equal width and then relate the length to it, and let the length equal W plus 6. And I will use the area formula A equals LW. Remember, I need units squared in the end in my final answer. I think this one has some kind of typo here. It does. It gives me, it's the first question says the perimeter of the tablet of the graph paper is 48 inches squared, but it shouldn't say squared. That should just be linear units, but we need to use that information to find the area of the graph paper. So following the same process as we did before, I'm going to put this area equals length times width, just kind of off to the side because we'll use that later. So sorry about that. That's a little confusing. So we're just going to use the perimeter first using that same formula. 48 equals twice the length. Our length we are representing as W plus 6 from the information given, and then plus twice W. That's just part of the formula. And we're going to go ahead and figure out what that width is, and also the other dimension. We can figure out length from that, and then we can plug those values in for area. So go ahead and do that real quick. Now, once I have the dimensions, I just went and distributed the 2 there. So I have 48 equals 2W plus 12 plus 2W. Then I combine like terms and solve. I get W equals 9 and length L equals 15. And I'm just going to plot those in for my variables here in the area formula. So I have area will be length is 15 times width is 9, and go ahead and calculate that out, and you will get 135, and that is in inches, and that is inches squared. So you can just say the area is 135 inches, or you could just say square inches also. So now we have one more problem, a volume problem. And this reads number 6, find the dimensions of a shipping box given that the length is twice the width, the height is 8 inches, and the volume is 1,600 cubic inches. So using your volume formula, V equals length times width times height, just need to get everything in proper relationship with one another. So we're gonna piece that together. So see if you can figure that out, and I'll go through that in a minute. So pause the video and try. So what I did for this problem was mark up the problem itself. Length is twice the width. I just wrote L equals 2W. The width is obviously just W, and the height is H, and the volume is 1,600. So now we can fill in everything and figure out what the dimensions are, the length and width, because we have it now in terms of one variable. So now I've plugged everything in. I have 1,600 equals 2W is my length times W times 8 is my height. So I end up with 1,600 equals 16W squared. I'm going to divide both sides by 16 and then take the square root of both sides. Is where I have a plus or minus situation because I'm solving for the square root of a variable squared. So I have 100 equals W squared, then take the square root. I get W will equal plus or minus 10. Well, we only want the positive for any kind of length. So I choose the positive 10 for W. Then my length is 2W, which is 20. And my final answer is the dimensions of the box are 10 inches by 20 inches by 8 inches, because remember that height was given. So that's it for 2.3. Thanks for watching. Have a great day.